push that rock with some math. So the rules for integration, let's rush through them fairly quickly. So linearity, we know you can integrate separately because integrals are just like derivatives and limits, and you can integrate across plus. You cannot do that with exponents, radicals, cosine, sine, all the other operators before now, but you can with limits, derivatives, and antiderivatives. This is another part of linearity. If you have a constant like this multiplied by a function, kick it out. And you have k times the integration of f of x with respect to x. Boom. Don't confuse that with the slope rule. This is just a constant, and of course the antiderivative of that is kx plus c, because if I take the derivative of a line, I get the slope. Boom. And we had give birth to the mother, so now we have to slide the mother back up there because this is e to the x plus c. See, we have the derivative, which was the mother that came out when we gave birth, so we got to slide her back up to get the mother. Get it? Okay, got it. Won't forget it. Now, what is this? What is secant x tangent x the derivative of? Oh, well, it's the derivative of secant x, of course, plus c. You remember that. You derived it. What about this? You derived that the derivative of cosecant is negative cosecant x cotangent x. So it has to do with cosecant, but it must be negative because I don't have a negative in here. See, if I take it over this, I get the negative of that, and then the negative would multiply by the negative and give me a positive. Okay, that's nice. And what about secant squared? Oh, well, that must have been tangent because the derivative of tangent is secant squared. Yeah, there you go. That's not bad. What about cosecant squared? Oh, well, that must be negative cotangent x plus c, because the derivative of cotangent is negative cosecant squared, and then the negative times the negative will give me this positive. So there we go with that. What about sine? Oh, well, let's see. The derivative of cosine is negative sine, so this will be negative cosine x, because if I take the derivative of negative cosine x, I kick the negative out and just take the derivative of cos. That's cos. Okay, and it doesn't look like cos, but it is. Now the derivative of cos is negative sine, but I have this negative out here, and so it gets to positive sine x. So the antiderivative of sine is negative cos. And the antiderivative of cos is sine, because, of course, if you take the derivative of sine, you get cos. Now, this is a nice little, the derivative of sine is cosine. Yeah, I did that right. So this leads us to a nice little quandary that we're going to always get this confused. So Miss Hatzel taught her students this nice little trick, and it seems to work. So I'll borrow from Miss Hatzel and teach y'all this nice little trick. So we think of this is 1, 0. This is 0, 1 on the unit circle. This is negative 1, 0. This is 0, negative 1. And we think of the, cosine is always the x value. So this is cos x. And then sine is always the y value. So we think of this one as sine x. Okay. So we're thinking of this one as cos x. And we're thinking of this one as sine x. Now, the derivative of sine is cos. The derivative of cos is, notice this one is in the y position, but it's negative, so it's negative sine x. The derivative of sine x, well, that's going to give me negative cos x. And the derivative of negative cos x gets me back to sine x. Now, what if you're anti-differentiating? Well, instead of going clockwise, you go anti-clockwise. So I go this way. And so the antiderivative of cos is sine. And the antiderivative of sine is negative cos. And the antiderivative of negative cos is negative sine. And the antiderivative of negative sine is back to cos. Maybe that'll help you. Maybe it'll confuse you more. So anyway, there we have it. Now, what about this? Integrating b to the x. Oh, well, then that'll just be b to the x. And then normally when you take the derivative of this, you get a natural log of b. So we need to compensate for that. And so it's the natural log of b reciprocal. And don't forget your plus c. And then let's see what else we got over here. Oh yeah, we know this. This is the natural log of the absolute value of x plus c. Yeah, naturally. Okay, there's nothing new there. Well, what about this? Oh, this is power rule. You add 1 to the power, put the reciprocal out front of the new power, and then plus c. Don't forget that. What's this? Oh, maybe you've forgotten this one because we have not stressed this a lot, but you did derive this using implicit differentiation. And the antiderivative of this is, who remembers? Arc tan x, because if you take the derivative, y'all derive this rule. If you take the derivative of arc tan x, you get 1 over x squared plus 1. You derived it, but we only did it once in class, and we're not having tests in this class, so you may have forgotten. Oh, what about this? Well, this is arc sine of x, and don't forget your plus c. And there are all the anti-differentiation rules in a nutshell. I've often heard of a book in a nutshell, but most of the time it's a nutshell in a book.